Hello and welcome back to activity 24.2. We're going to start, thanks Coach Williams again, we're going to start by going over numbers 9 through 12, 15, and 17 from 24.1, making sure those make sense, and then we'll go ahead and look at 24.2. So back to 24.1, number 9 actually asks you to simply draw a tangent line to the circle and then draw a diameter as well, so just a simple drawing like that. Number 10 asks you to explain the relationship between those two. Keep in mind, diameter is simply a radius that goes all the way through the circle, for lack of a better term, meaning that they are going to be perpendicular. So tangent lines are perpendicular to radius, it's also going to be perpendicular to the diameter. Okay, so that's 9 and 10. Number 11, they're kind of asking you to compare two people's reasoning. Wyatt is the one that's reasoning is correct there, because he said that a chord can't be tangent, and that's true. Tangent only touches the circle once, chord touches twice. So 1 can't equal 2, so Wyatt is correct there. Number 12. Number 12 was the one that I told you to change the drawing in your PDF or in the book. I wanted you to have the 36 be this little segment right here that goes from the edge of the circle to the corner, and then the 42 goes up here on top. 42 is the length of the segment that's tangent, okay? If you do that, this is what the math looks like. If you didn't do that, it's going to be different. So if you didn't do that, I want you to stop, pause the video, change it, and then go work it, and then come back and we'll talk about how you get the answer. So what I did here was I looked at Pythagorean theorem, and we'll use a different color so you can kind of see it. We looked at Pythagorean theorem with this being a right triangle, and my right angle being up here, which is where it has to be at the point of tangency, okay? I had a radius here, I also have a radius length here, and that's where this r plus 36 comes from. When I square r plus 36, I get r squared plus 72r plus 36 squared. Now what you'll notice is you have r squared on both sides, so I can cancel the r squared. It keeps this as a simple problem, okay? And I just need to solve for r, so I'm going to subtract 36 squared from both sides, so I get 42 minus 36 squared. 42 squared minus 36 squared equals 72r. 42 squared minus 36 squared is 428, divided by 72. I get my radius is 6.5. And if you'll plug that back in and check, turns out that 6.5 squared plus 42 squared equals 42.5 squared. And those would be your three lengths, okay, just as kind of an FYI. Hopefully that makes sense. Number 15. 15 and 17 actually use the same drawing. And so what I did is exactly what I suggest you do, is just draw the drawing twice. Okay, I copied the drawing out of the book. In number 15, they say, hey, this length is 12, and this length is 5, and this length is 13, and they said, is the line tangent? Well, the way we know if the line is tangent is we'd have to prove that the line is perpendicular. And so really, if we can prove that this is a right triangle that's created here, if I can prove that this is a right angle up here, then I can prove it's perpendicular, and therefore it's tangent. And so that's what I did. I used the converse of the Pythagorean theorem. 5 squared plus 12 squared equals 13 squared. Which implies that's a right triangle. Because it's a right triangle, it means the two segments are perpendicular. Because they're perpendicular, it is a tangent line. Okay, hopefully that follows. Number 17, they change up the values, and they're asking you to find yt. This time they give us the hypotenuse, and they give us one of the legs, and so we're going to do 24 squared minus 18 squared, which is 252. Square root of 252. We're reducing radicals here. I know you can put it into calculator to get a decimal, but it's good practice to do with the radicals because that's what you're going to see on the test. So square root of 252 is 6 times 42, which reduces to 6 times 6 times 7. There's two sixes, so the 6 goes out front. So our final answer here is 6 square root of 7 for number 17. Okay, hopefully that makes sense. Let's go ahead and talk about 24.2. 24.2, we're looking at page 339. And what we're looking at is theorems about chords. Theorems about chords. So let's just remember, what is a chord? A chord is a segment whose endpoints are on the circle. So let's draw a chord, yeah? We're going to have 1 point here, 1 point here, and we connect those dots. That's a chord, okay? Now let's talk about these two theorems. The first one says, if a radius is perpendicular to a chord, then it bisects the chord. So let's look at what that would look like. Let's say we've got our center here, and I'm going to draw my radius that is perpendicular. Keep in mind, if you get 190, you get all four, so you kind of a little window thing going there. This theorem says that if this happens, then this length has to equal this length, okay? So let's say this is A, this is B, and this is C. If AC equals 20, then AB equals how much? That's right, 10, okay? each part would be 10. So if the whole thing was 20, I would get 10 over here and 10 over here. All right. Also, I have that right angle. So what you're going to see happen a lot of times is you're going to actually have to work with the radius. You're going to have to draw that line and deal with that right triangle. Okay. And so you're going to see some problems like that, just as a fair warning. But that is the first theorem that we're looking at in 24.2. The second theorem deals with the fact that if you have two chords in the same circle and they are congruent. What does congruent mean? Same length. Okay. If you have two chords that are the exact same length in the same circle, then they are equidistant from the center. All right. They're equidistant from the center. What does that mean? That means that, and this one's a little more complicated to draw, so we'll draw a little bigger. Let's say we have a chord here and a chord here, and these chords happen to be the same length. So let's say this length is 10 and this length is 10. Okay. What this theorem is saying is that, let's say here's our center, right? And let's kind of walk ourselves through this as to why these are exactly the same. If I were to draw my radiuses such that they are perpendicular, so I get a 90-degree angle, what happens? It cuts this in half and I get a 5 here. Everybody okay with that? Okay. And I'm going to do the same thing here. I'm going to draw it such that it's perpendicular, and so it's going to cut it in half and I'm going to get a 5 here. Okay. We good so far? All right, now watch. I'm going to draw my radius. How long is my radius? I don't know. I'm just going to call it my radius. And I'm going to draw my other radius, and I'm going to call it my radius. Okay? And this, we're going to call this D1, and we're going to call this D2, because those are my two different distances. What this proof is saying is that those distances have to be the same, and I'm going to show you why. Technically, D1 squared would be equal to r squared minus 5 squared. And D2 squared would be equal to r squared minus 5 squared. We had this thing back on page 26 of the PDF called the transitive property. It basically said if A equals B and B equals C, then A equals C. Well, that's what we have here. We have A equal B and C equal B. They both equal the same thing, therefore they have to equal each other. So D2 squared equals D, that's not a D, bad teacher, D1 squared. Okay, and we could take the square root of both sides and we would get D1 equals D2. So the distances have to be the same. And so again, you're going to see a lot of right triangles built into these. If you want to see that done better, not to say mine wasn't perfect, but if you want to see it done better, if you'll go in your book and go to page 340, they're going to show you the steps. And then on 341, this is where you're going to start. 341 is question number 3. They give you all the reasons for the proof of what I just showed you. They give you all the reasons and they ask you to put them in order. Okay, so really good, just practice, kind of a reminder, because it's been a little while maybe since you did some proofs. So question number 3 is a good reminder. Don't stress on it too much, but see if you can't put those reasonings in order. And then your assignment that I want you to work on, you're going to do number 4. I just want you to kind of think through question number 4 and write about it. And then I want you to actually work number 6 and 7. Number 6 and 7. So we're looking at number 3 on page 340. Then we're going to do number 4, 6, and 7. 3 on 341. And then we're going to do numbers 4, 6, and 7 on 342. Take really 5 to 10 minutes. That should not take you a lot of time. And then come back and see me when you're done with that, and we'll look at the next section.